All right, welcome everyone to Module 2, Greenhouse Gas Accounting Basics. So this is Module 2 in a series. The overall purpose of this series is to arm everyone in the audience with some basics on renewable energy, some skills to understand how to evaluate, set, and execute a renewable energy procurement strategy. If you missed Module 1, we talked about some of the climate change basics, grounded ourselves in some of the broader context and around sustainability and why renewable energy procurement is important. So go back and check out that first module if you missed it. In this module, we're going to be getting into some greenhouse gas accounting basics. So understanding what greenhouse gas accounting is, understanding scopes 1, 2, and 3 emissions. We're going to focus particularly on scope 2 because this is where your electricity emissions sit. And by the end, hoping you'll have some of the tools necessary or some of the groundwork necessary to move forward with a renewable energy procurement strategy. So yeah, as you can see, this is the second module of 9 modules. In later modules, we're going to be getting into more of how to set a renewable energy goal, both internally and sort of externally. We're going to be looking into what renewable energy is, the different types of renewable energy procurements, inclusive of energy attribute certificates, utility programs, on-site renewables, and power purchase agreements. And then we're going to wrap up the module series with how to create a renewable energy procurement roadmap. Okay, let's get technical. So greenhouse gas emissions are sort of your overall footprint of emissions associated with your operations as an entity. These emissions are broken into 3 scopes. There's scope 1, 2, and 3. The purpose of breaking emissions into scopes is to understand the different layers of influence that you as an organization have over different types of emissions. So scope 1, these are the emissions that you have most direct control over. So, you are selecting the fuel sources, you are selecting how often these sources are used, the extent to which they're used, and you can very finely tune that as a business. Scope 2 emissions kind of step out a little bit more. These are your electricity emissions. So these are obviously you're turning the lights on and off. You can implement energy management systems. You can retrofit your buildings to be more energy efficient. But ultimately, you're not, you don't have much control over the electricity grid. You don't have a ton of control over the suite of resources, the coal or the natural gas or the wind power that's providing the electricity to your building. So you have a bit less control over those emissions, but still a fair amount. And then scope 3 emissions are kind of everything else. So these are upstream of your business. So your supply chain, the inputs that you need that are required to run your business, as well as the downstream emissions. So if you make a product, what are the emissions associated with someone using that product or disposing of that product? So you can see in this graphic here, we have scope 1 emissions are right in the middle. That's that's where you're reporting, that's where your company sits. And these are typically, fuel combustion sources. So things like natural gas to heat your building, gasoline to power the vehicles in your vehicle fleets. Sort of your direct emissions, maybe jet fuel for a corporate fleet, things like that.
And data centers would be, say, diesel to power the backup generators.
Sure, yeah. Scope 2, so we talked about scope 2 being largely purchased energy. So this is going to be largely purchased electricity. So data centers require a lot of electricity, as we know. And so this is all the electricity that you are purchasing to run those data centers. So again, you have some control over the energy efficiency of your operations, but ultimately less control over the sources of that electricity. And then scope 3, so these are broken into 15 categories of emissions. There are seven upstream and 8 downstream categories, or maybe that's the opposite. But these are things like, you're purchasing materials to construct your data center. Your company, your employees are commuting back and forth from your offices. You have business travel. These are things that go into your upstream emissions, and then downstream might be, someone using the data center, or for data centers, the downstream emissions are kind of less. It's less impactful.
For colo, it's perfect. So for colo or cloud provider, it's your customers using your equipment, right? So you own and operate that equipment, but you wouldn't have that equipment unless your customers were actually using it. But you can't control how much the customers use it, and therefore that's part of your scope 3 emissions.
Yeah, so just a quick observation here. So if I'm an enterprise and I'm moving workloads from my on-prem data center to a cloud provider, my responsibility shifts from scope 1 and 2 into scope 3.
Correct.
And then the cloud provider would then become accountable for scope 1 and scope 2 kind of stewardship on my behalf. And what's really essential here is then that some sort of carbon tracking would be really important, because the customers would need to see the environmental impact they're having then on those choices that they made with their cloud providers and upstream supply chain. So I think, am I right in also saying that the more you go to scope 3, the more complicated it gets? Because it certainly looks that way. Scope 1 is very nice, very clean, very easy to manage.
Good data.
In scope 2, but an awful lot will be in scope 3.
Yeah, that's a really good point, Guy. And if you think about it, say for example, if you're Ford and you don't actually manufacture the whole car, right? You may compile all the pieces and put the pieces together. Or if you're a computer manufacturer, you don't manufacture the chip. So the idea is that the supply chain is multi-tiered, and it's sometimes very difficult even to get data from your direct supplier, let alone that supplier, and on and on and on. So it's absolutely true that the scope 3, first of all, it's generally by far the biggest part of the company's carbon footprint. And it's also the hardest one to get data on. Nonetheless, what we're seeing is that in the early days of carbon footprinting, there was a big focus on scope 1 and scope 2. And because that was something that was more or less in the direct control of the company. But now, because there's a recognition that not only is the largest part of a company's carbon footprint in the scope 3, but now there's a desire for companies to put pressure on their suppliers to reduce that portion of the carbon footprint. So that's what we're seeing is everybody's putting pressure on everybody else, because inevitably everybody is a supplier and a customer of someone else. And that's the idea, is right. And as we do that, our data will get better, because we know VMware, we're already collecting data on our own scope 1 and scope 2 and some of our scope 3. And now that's information we can pass along to our customers who can then compile their scope 3 from what data we provide them. So it's sort of an evolution, and no data is perfect. This is definitely not, I would say, early days. I mean, reporting's been going on for probably about 15 years now. But the idea is every year it gets better and better and better. And the demand for better data and the demand for better reporting keeps increasing. So you can't really avoid it.
Yeah. You want an integrated supply chain view of your carbon environmental impact. And I totally get that. It's an end goal. It's going to take many years to get there, if we get there at all. But I think it's definitely something that's really worth highlighting, though, the realization of the complexities in scope 3. And like you say, obtaining that information around the sustainability within your supply chain. And we live in a very, very, very complicated supply chain world, global supply chain world now. And this is why this is, quite hard to kind of get to grips with. But, if you're a cloud provider, you've got enterprises moving from the scope 1, scope 2 into your scope 3, you're essentially then going to become responsible for their scope 1, scope 2, which is great for the enterprise because they fast track their sustainability by jumping on board. But it's unless you've got your metering and supply chain all sorted, it's going to be very difficult for you to attract those customers.
Yeah, and adding on to that point, we're seeing now customers going to their cloud providers saying, provide me with my carbon footprint in your running my workloads in your data centers. And so we see Microsoft was the first one to come out with the cloud reporting, and then Google and now Amazon as well, AWS. So we expect that there's going to be continued pressure on the other cloud providers to provide that carbon reporting to their customers.
Yeah, and just worth noting, we have that in vRealize as well.
Yeah.
Yeah, great points. I think just to put a bow on it, it's helpful to think of, your scope 1 and your scope 2 emissions. All of those are someone else's scope 3 and vice versa. And so, you can do a greenhouse gas inventory and look at your emissions, but it's important to understand those are actually someone else's emissions also, and they might come knocking and say, hey, we want you to bring those down. So yeah, nice discussion there. So I do want to focus on scope 2 emissions because that's the world of electricity. That's kind of the renewable energy context that we're focusing on with these modules. Scope 2 emissions are largely just purchased electricity from the grid. As I said earlier, sometimes you kind of know where you're getting your electricity, but a lot of times you're just plugging into the grid, and whatever electricity is on there is what you're getting. The way that we calculate scope 2 emissions is we take the volume of electricity purchased. So if you remember from module 1, we talked about kilowatt hours and megawatt hours. So that's the volume of electricity that you've consumed. Then we apply an emission factor to it. So the emission factor will be basically, carbon emissions per unit of electricity. And then we get to our carbon emissions. So these emission factors will change depending on where you are, depending on what the source of electricity is for you. For example, if you're located in California, the emission factor you would use would be a local California emission factor for all of the electricity that goes into the grid in the California grid. Versus if you were in the UK, it would be similar, but you would use the emission factor local to you for the electricity that you're physically taking off the grid. There are two ways of calculating scope 2 emissions. There's the location-based method, which is kind of what I just described, which is where you're not necessarily specifying where you're getting your electricity from. You're just saying, well, we're pulling from the grid, so whatever the grid emission factor is, that's going to determine our emissions from electricity. The other method is called the market-based method. This method says, well, I do have some control over who I'm sourcing electricity from. In some places around the world, you don't just, you're not just using the utility that's there. You have a choice of which utility you're able to use. You're also able to go and source your own electricity through a direct contract if you want to. And so the market-based method accounts for that by saying, okay, well, instead of taking the grid average emission factor for just my physical location, I'm going to look at the contracts I have in place. And maybe I have a contract directly with a wind farm. Maybe I have on-site solar. Maybe I have, maybe I'm signed up to a program with my utility that specifies a certain portfolio of electricity, and that has a different emission factor. So market-based accounting is important because this is what allows your organization to see emission reductions, right? If we're just using the location-based method, we're just kind of going off what the grid is using, then we're beholden to the sources that the utility wants to put onto the grid, right? Maybe they're going to do a good job to decarbonize, maybe they're going to switch to renewable energy, but maybe they're not, and we don't have much control over that. The market-based method allows us to say, no, we're going to take control over where electricity comes from through specified contracts, and that's going to allow us to realize emissions reductions, because now we're using we're sourcing from somewhere that has a lower emission factor than the grid average. So yeah, I touched on some of this. Benefits of the market-based approach over the location-based approach is that it allows you to make those emissions reductions, and it allows you to implement a strategy and see your emissions reduced over time. So you might, tackle one site one year and another site the other year to source directly from a wind farm here or a solar farm there. I mean, you can kind of use that over time to lower your market-based emissions. There's a lot that goes into greenhouse gas accounting, but luckily there are a lot of tools out there for you. The main sort of greenhouse gas accounting Bible, if you will, is the Greenhouse Gas Protocol. So this is a group comprised of experts from a few other groups, but mainly the World Resources Institute. They basically just set the rules for how to do greenhouse gas accounting. So that's inclusive of scopes 1 through 3. There's a document specifically called the Greenhouse Gas Protocol Scope 2 Guidance, which goes into great detail about how to calculate your electricity-based emissions. So I would highly recommend you getting familiar with that if if you're new to greenhouse gas accounting, or to talking to to experts that are quite familiar with this document.
And Nelly, just to add on to that, it's obviously this is not a regulation, right? There's no government saying this is how, sort of like the way we have gap accounting for financial reporting. It's really, this is all voluntary, but the organization, the World Resource Institute, has established this protocol. Now there are other protocols, but generally most of the globe is following this particular protocol. And it's fairly straightforward. It may sound complicated, but it's basically how much are you using times how much carbon emissions does that particular use, like a kilowatt hour, produce, and that sort of gives you your carbon emissions. So yeah, I just want to make that one comment.
Yeah. And, there are a lot of other frameworks that we're going to be getting into in subsequent modules like Carbon Disclosure Project, CDP, or RE100, or the Science Based Targets Initiative. All of these groups reference back to the Greenhouse Gas Protocol. So if you're aligned with Greenhouse Gas Protocol for how you're doing your accounting, you're in good shape for your other sustainability commitments or kind of anything you do in the sustainability world. Okay, so that wraps up the second module on greenhouse gas accounting basics. Hopefully that wasn't too complex, and I think it's going to provide you with a lot of the groundwork and the tools to to set you up well for the rest of your renewable energy procurement process. So yeah, I don't know, Guy and Nicola, if you have anything else to add to wrap up this module.
Thanks, Elliot. I just think it's a really nice model, really simple to understand, really interesting to understand as well. When you, particularly like I said, when you're looking at things like migration to cloud and considering your supply chain, I think the greenhouse gas kind of framework nicely aligns to a logical way of thinking about it. So I'm excited to see how it's going to be used in the future modules.
Exactly. Yes. So looking forward to seeing everyone at the next module.
Thanks a lot.
Thanks.